All right, well, thank you for coming. I hope lunch was good. I really appreciate everybody being here. I know there's some other awesome talks, so I will make sure to make this one at least as awesome as the others. So this is about the Athens Project. How many folks have heard of this project before? Oh, that's cool to see. All right, so it's a little like a third or so. So we're going to go in some detail about this project, and we're also going to see some demos of this project live. So cross your fingers for the demo gods and for Wi-Fi, because they're going to be downloading like 90 megabytes in hopefully a short period of time. So I am a creator of this project and one of the core maintainers, and of course I'm really excited to talk about it today. So I want to give a little bit of an introduction on why this project exists and why we are here to talk about it. So by now, I think everyone is aware of modules, and some of us might be using Go modules to do our dependency management in Go. And if we're not, we might be thinking about it, or at least we know what it's all about. So that's why I say that it's standard. We've had modules in some shape since Go 1.11, and now, of course, we're past 1.13. And the system might not be perfect, but it's fairly baked in now to the Go toolchain. So the question that some folks ask, including myself, is, are we done? Is there anything more we need to do to handle dependency management in Go? Or is there anything we need to do to make it better in Go? And I don't think we're done. I think there are more challenges to cover, and now that we have modules and a good dependency management tool, we have to start meeting those new challenges. So let's talk about the challenges now. So once we've got a good system, now what more do we need to do? So going back to the very first solution that we had for dependency management in Go, we had version control systems. And essentially, we had this go get command. I think every single one of us have used this command millions of times. And the basic way that go get worked is it would talk directly to the version control system and do effectively a git clone or whatever the VCS command line tool was for that system, to pull the code down at a specific version, or maybe not even at a specific version, maybe just the latest version. And it would bring it down and put it into your Go path. And every time you built your code would build against the code in your Go path, and that would be that. Since then, we've made some iterations. We've introduced, of course, the vendor directory, and the vendor directory would insulate you from the global Go path. And you could build your code with a specific version, and you could build other projects' code at different locations with a different specific version of the same package. And of course, then after we had the vendor directory, we had a variety of tools that would help us manage versions in a specific vendor directory. So we had Glide and dep and godep and a variety of other tools that all built on this technology and got faster and better in other ways. But there was a fundamental problem with all of those tools, because there was a fundamental problem with the underlying technology that pulled directly from version control systems. And that's why I say this is a sort of a disaster waiting to happen. And I don't want us to pull dependencies anymore from version control systems because of the risks that it carries. So let's look at some of the risks. So if we're pulling directly from version control systems, well, the owner of the repository we're pulling from could just accidentally delete a tag that we rely on, or maybe purposefully delete the tag if they're just done with it or they found something they didn't like about it. And if they do that and you rely on that tag, if you're using Go modules, your build will break. If you're using other systems that relied on the vendor directory, your build might not even break, and you might be unknowingly using code that has been changed out from under you. And the same thing goes for if someone wants to just delete a repository. Now, in all cases, your code will break, unless you've checked in your vendor directory, in which case now you have to own that code forever. because there will be no upstream for you to pull fixes down from. And of course, on GitHub, deleting a repository is fairly quick and easy. It's a click of a button, and in some cases, you have to put in your password. So if you rely on a package, you're relying on the package author to just not click that button ever. And you're crossing your fingers that if they do click that button, someone else or you have checked in that code and maybe has even pushed a copy of that code up to somewhere else on GitHub. Even easier than deleting is to rename the repository. And on some systems, this will break your build. On other systems, this will not break your build. On some systems, if the code has changed, just as in the tagging case, if the code has changed, in some cases, it will break your build. And then on other cases, on other systems, it will not break your build, and you'll get changed code kind of slipped in out from under you. And then there are circumstances outside of your control and outside of the package owner's control. And that is because we're relying on GitHub. GitHub could go down. We've seen GitHub have outages before, and it's not GitHub's fault. It's not anyone's fault, really. But if it happens, unless, again, we have checked in our entire vendor directory, we are out of luck. Our builds will always break. If we're using go-get, for example, our builds will always break. So, in essence, I always boil it down to the git push-f case. Of course, there are other cases that can break your app, but the most common case that I have seen, and some other folks that I know have seen, that have broken apps is if someone accidentally does a git push-f to a repository that you depend on. So I see some smiles out there. I think some folks know what I'm talking about. And there is no single worst case that we've seen in the past. But this has been the primary reason for applications either breaking, builds breaking, or for code being slipped in out from under you in your application that you didn't even know changed. So I'm Aaron. You probably know that already. I work at Microsoft in the Azure group on the open source engineering advocacy team. And I want to talk about how the Athens Project is one pillar, one part of the solution to all of these git push-f and related problems that I laid out and that I think we've all seen at some point in our Go development journey. So in the module specification, there's a lot of specification. It's a textbook long, maybe if you printed it out. There's a small section of that specification that outlines an HTTP API that allows you to set up a server, an API server, that the Go tool can download modules from. Okay, so the API has some metadata endpoints that will list versions of a specific module and give you the latest version of that module. And then you can get metadata of a specific version of a module that's frozen in time. So even if the module changes on GitHub, the metadata will stay the same as it was the very first time the module existed on GitHub. Same thing if the module is deleted. The metadata will still be there even if the thing is deleted out from under you in GitHub. And then the most important one, of course, is a zip file of the module source code at that version. And again, really importantly here, the source code is frozen in time at that version. So the very first time the thing exists in GitHub, the source code is pulled down, and only the Go source code, so no website or documentation assets or anything else. It's just the Go code. It's zipped up into a zip file, and then it's stored, frozen in time. Anything changes in the back end on GitHub or anything, including deletion, the code will still be there in this zip file. So more importantly than all those awesome properties about code being frozen in time and immutability and other things related to that, is that this is the first time that the Go community has had an API that's purpose-built for dependency management. So before this API, we've always been using the Git API or the GitHub API or the GitLab API or the Mercurial API or so on and so forth. So it's really important that now, this is the first time, now we have an API that's just for us. That's just for dependencies. That's just for modules. So now that we have that, we can do all sorts of awesome things that optimize dependency management for Go, and not trying to take other APIs and fit them into our use case for Go. So of course, we have an API server. We have an API. We're going to build API servers. So essentially, instead of having the Go Get tool pull directly from VCS, we're going to have an API server pull from VCS. And we're going to have the Go tool pull down code from the API server using the module download API that we just saw. Okay, so one layer of indirection, and there's a quote out there somewhere that says the solution to every computer science problem is a layer of indirection. So we're going to apply that here. And we'll see that it doesn't add too much complexity to the end user workflow if you're building an app. And it also doesn't add too much complexity to the experience of you writing a library that others will depend on. And so now that we have the API server that's serving up this API of zip files and .mod files and all the metadata that we saw in that API list, we can now separate out two concepts. So on one hand, we've got code in development. And that's the code that lives in GitHub that can change all the time. And that's on purpose. If you're developing some code in GitHub, you want it to change. You want to be able to obviously push new commits and merge pull requests. And even if you want, delete tags and even maybe delete the repo. But on the other hand, for the people that are depending on your code, we want to provide an asset. That's the zip file. We want to provide some packaging of that version of that module that is fast and efficient to download, and that won't change, even if the code in development does change. And so as we've seen in the past, in the history of Go, we've seen that as we add more and more code in development and more dependencies, entropy has set in, right? So if we add 10 more dependencies, we're more likely to have one of those dependencies be deleted from GitHub or change out from under people in GitHub or have a tag deleted out from under somebody in GitHub. But when we introduce this concept of a dependency asset, now we're taking that code and we're freezing it in time. So we're actually less likely to have the entropy. We're more likely to encourage stable builds because that code that people depend on won't change. But on the other hand, now that we have this separation between the code in development and the code, the dependency asset, or the code asset, we introduce this possibility of, now that we have a separation between the two, we are now separating the module maintainer from the person depending on the module. Or in other words, we run the risk of introducing a registry. Now, registries aren't bad, but we can see sort of in the history of software development and dependency management, there have been instances where registries have proved to be problematic. And as a community, we should learn from that history. So one notable example is in the Node package manager ecosystem. So does anyone work with JavaScript or Node? Raise your hand. Yeah, okay. Does anybody remember the left pad incident, so-called? Okay, so a lot of heads nodding. Okay, so for those who don't, quick summary. Left pad is a small little dependency in the JavaScript ecosystem that practically every big library depended on. And in the Node ecosystem, there's a registry that provides all the dependencies to most projects. And that registry is called NPM. So one day, the NPM organization that owns that registry was forced to take left pad out for legal reasons. And once that happened, everyone was depending on it, so everybody broke. It was at the root of tons and tons of dependencies out there, including like React and Angular and big projects like that. So everybody broke because everyone was depending on one single registry. So that is a big marker to us. We shouldn't be designing a system that implements these download APIs that has this single point that can fail. So in other words, we want the awesome parts of a registry, like it being really discoverable and being super reliable. But we don't want the property of the registry that it can fail, that if one thing fails, then we're all going to be broken. Because that's no better than what we had before. It's actually worse than we had before, because before, if one of our dependencies failed, at least we could get the other ones. But in the registry case, it's possible that if the registry fails, we could maybe not be able to get any of our dependencies. So Athens steps in here and can start solving this problem a little bit. So right here, we have pretty much the same exact architecture diagram as we had before, where we put the API server in the middle of all these version control systems. And I'm proud of the Athens logo because one day I went on to gopherize.me and I made it. So it's one of the 2 billion or whatever possible combinations. So Athens sits in the middle there. You point go get to Athens, and Athens implements that download API. So it's immediately swappable with any of the other module proxies out there. And as we'll see, you can also combine it with the other module proxies out there. So you point go get at Athens. And Athens can not only talk to version control systems, but it can also talk up to some of the existing hosted module proxies out there. So JFrog has one called gocenter.io. Sonotype has a gonexus.io. And of course, the Go team has proxy.golang.org. So Athens can also talk to those in addition to the version control systems. Okay. So it sits here in this place that allows you to not have to rely directly on version control systems and also not have to rely directly on these hosted things, or these things that if everybody starts relying on them, they kind of start looking like a registry. So now we have an option to augment that. And the really important part about Athens, the most important part about Athens, is that, you can't see anything about Athens. All right. We're just going to pray that this doesn't move anymore. The most important part about Athens is that it maintains its own database that you own. So Athens has storage drivers. You can store all of your dependencies on an attached disk in the cloud, or on S3, or in MongoDB, or somewhere else similar to that. And you point Athens to your MongoDB, or your file system, or your S3. And you control all the dependencies that sit in there. So if the code is offline or Athens is unreachable, well, at least it's your fault. And you can control what happens, and you can fix it, instead of relying on a registry to fix it. And that part is really important, because now you can kind of start controlling your own destiny a little bit. So I'm actually going to show what it's like to sort of control your own destiny. I built a little web app using the Gin framework, and it uses a bunch of other dependencies to deal with templating and so on. And the web app shows pictures of dogs and cats, so I have everybody covered, whether you're a dog person or a cat person. And we're going to build this web app in 2 different ways, both using Athens. And we're actually going to simulate breaking something, not the code, but actually breaking our dependency management, and then recovering from it using Athens. So all of this code and this demo stuff that I'm going to show is on GitHub, and I will, of course, there's a link that I'll give at the end, and so you can go and run this yourself as well if you'd like. But for now, we're going to go through sort of the demo on VS Code. So we're going to build our code using Athens, and Athens is going to be pointed to an upstream version control systems. So if I need to get github.com/gin/gin, that's going to tell Athens to go do literally a git clone to get it down from GitHub, and then to have Athens store it in its own storage, so that from that point on, the second, third, fourth, and so on time that I do the build, there's going to be no GitHub interaction. Athens will just store it, will serve it directly out of its own storage. Okay, so there are quite a few different ways for you to run Athens. I'm going to choose Docker because it's really quick to start up in a demo, and you don't have to watch me fumble around too much on the command line. So let's do that. We're going to run it here. There's a little bit of logging that we'll see. And basically, this is Athens running on port 3000. And I can go open up a new tab in my terminal, and I can tell the Go toolchain to use the download API for everything. So don't use VCS anymore. Always use the download API, and always point the download API to my Athens on localhost. So if you're doing this for any kind of, well, first of all, if you're doing this, don't do what I just did. Actually specify the environment variable. It's called Go Proxy. And if you're doing this in a production context, probably use HTTPS. I actually think the Go tool now won't let you do HTTP unless it's localhost. So obviously use HTTPS for a production environment. And once you set Go Proxy, like I said, now the Go tool for every Go run and Go build and Go install and every command that does any dependency management will always use the download API and nothing else. Okay. So the last, yep.
If I understand correctly, now the API communicates with JFlow or Nexus.
This one will only be communicating with version control systems. But you can configure Athens if you'd like to talk to the proxies, like GoCenter or proxy.golang, or 2 or 3 or 4 of those if you want as well. You can also configure it to talk to other Athens servers, or really anything that implements this API. So if you have a Java implementation or something like that, that would also work too. All right, so we've got our Go toolchain pointed up to Athens. The last bit is I'm going to delete my local on-disk cache because I want to actually show what happens when there's no cache dependencies on my machine and I have to go up to Athens to grab them. So I'm going to delete everything in my Go path. 1234 is my password. So if you ever get this, it's very easy. So another little side effect of this is you actually don't have to have your code in the Go path. So that's a side effect of modules in general. And that was a huge win for me because it was annoying to me to put in the Go path. But if you do go over to modules, then just keep that in mind. You don't have to be in the Go path anymore. All right, so the last piece here is we're going to run the code. We're going to run my web server, which is obviously going to have to build it. And because it's going to have to build it, it's going to have to pull down all those dependencies. So we're actually going to do the run in verbose mode. And that -x is going to show absolutely every execution that the Go tool is going to do. And this is going to end up downloading a ton of dependencies. And it's going to take a while because I think it ends up being about 85 megabytes of dependencies over the conference Wi-Fi. So while we let this go, I'm just going to show some of the dependencies we rely on. So there's 3 top-level dependencies here. And if we go look at our Go sum, which has all the transitive dependencies, there's quite a bit in here. So this is the Go tool looking on my local cache, seeing nothing, and then requesting the dependencies over the module download API up to Athens. And Athens has nothing in its own storage. So that's kind of like a cache miss, although Athens is not a cache because nothing gets evicted. Once Athens doesn't see it in its own storage, then it goes to the upstream version control system, grabs it, and then stores it in its own storage. So we can see the Go tool doing all of these things. And you'll notice it's doing some of these requests up to localhost, trying to get this one's on a line break, but you can see v1.0.2.mod. So that's one of those endpoints of the download API. Here's another dependency, Go spew, same thing, version number.mod. And we can just keep going down and seeing it doing .mod requests for everything. And now we can see we're switching to .zip requests. So this is the Go tool getting information on the version of the module that it needs, and then switching over and asking Athens for the source code for that module. So if we switch over to the Athens logs, you can see Athens is serving up this information. If we scroll way up, we can see Athens is now serving up .mod files. If we scroll down, now it's switching over to serving up Where are the zip files? Here's some zip files here. And then finally, serving up some of these .info files, which is a little bit of extra metadata about a specific module at a specific version. Now, looks like, are we done? Yeah, we're done. So notice that took as long as it took me to blab, so say a minute or two. I think I talk a lot but fast, so let's call it 2 minutes. So now we've got the thing serving on port 8080. Little just basic web app. I figured out how to use Bootstrap, so yay me. It's using the Buffalo plush templating system, which caused a ton of dependencies to be pulled down. So we're going to start with, well, let's get hands for dogs. Who likes dogs? Okay. Cats? Okay. Dogs wins by a tiny margin. So we're going to start with dogs, then we'll go to cats. Okay. So looks like the random number generator is not, it's doing okay. Yeah. So we've got some dogs powered by Athens. And now we're going to go and kill the server. We are also going to shut down Athens. And Athens was using an in-memory storage system. Okay, so Athens database, I was managing it, but it was in memory inside of a Docker container. So I just closed the Docker container, so Athens storage just got blown away. If you're in production, don't run an in-memory Athens storage. Probably obvious. But it can go away like that, just like happened here. So if AWS decides to shut down your server, you're out of luck. There's no, it's like someone just deleted all the repositories that you relied on. All right, second thing I'm going to do is I'm going to go and I'm going to re-delete the cache. This is my on-disk cache on my machine. So I'm going to re-delete that and make sure that the next time I do a build, the Go tool is going to have to go up and grab dependencies from the Athens server again. Okay, so now there's nothing else in my cache. I've got no Athens running either. And I'm going to shut off my internet, so Athens will not have the possibility of going upstream anymore. Okay, so I have the Athens database now on a file system, on a USB drive. So we're going to run Athens, and we're going to point its database to this. And this is going to be Athens database to build everything it needs, or to pull down everything it needs to run my app. Okay, so let's cross our fingers for this. So now we're not going to be using the network. We're going to rely on the bandwidth from my USB key through USB 3 to my machine. So let's see what happens here. All right, so we're going to export Go path. Let's do here. Export Go proxy to volumes. I have named, this is the product placement for Kingston USB drives. Athens archive. All right. So we are, that's not right. Let's do this. Export Athens, what did I call it? I called it Athens archive equals volumes, Kingston, Athens archive. All right. So now I'm going to run a pretty similar Docker command, except I'm going to tell Athens via some environment variables to say, okay, do not use in-memory storage anymore. That's not good. Secondly, use disk storage, the disk storage backend, and point your disk storage backend to the Kingston thing. So now Athens is every time it gets a request, it's going to look on the USB key. It's because I set this demo up, hopefully properly. It's going to find the dependency that it needs on the USB key for every dependency that my app needs. And it's just going to serve it directly up back to the Go tool. So not only should this work, cross your fingers, without Wi-Fi on, it should also be a faster build because obviously bandwidth from my USB key is going to be faster than bandwidth down through conference Wi-Fi from GitHub. So let's hope that this works. All right, same logging. I'm going to remove the local binary. I ran go run, so there's no binary. We're going to do a -x-v. Oh, that's not right. We're going to set localhost again because I messed up the Go proxy environment variable. localhost 3000. Let's try it now. So, a lot faster build. I didn't even have time to blab this time. I was mesmerized by the screen. No. It was a lot faster, though, because Athens is just going to this disk, this Kingston thing. It's just downloading stuff. It's not downloading anything, sorry. And it's just pulling dependencies right from here. So this is a technique that a lot of people who actually do this for their production builds, they call it sideloading. You can also do this with other storage backends like S3 or MongoDB, but it's most common with actually attached block storage in the cloud. You can take block storage and just move it around to all the Athens servers you need. And you don't have to actually rely on the public internet at all. So if you're at a really highly regulated firm or something like that, this is a great solution for you. All right, I didn't forget about the cat people. Did I break something? Probably. Anyway, we've got cats. As you can see, I'm not a great web developer, but I probably did something with bootstrap caching, but at least the images are not, they're sized properly. They're just not centered. So this is my favor. Sometimes I have the same feeling. All right. So I kind of hinted at a few things here. This is a fun demo. I also kind of hinted at like, why would you really want to do this in real life? But if I had someone to do drum roll, please, I would have done that right as I turned off my internet. But there's some real questions here. Like, why is this demo? What is this demo showing that's actually useful for people who really run this in their own production environments at their organizations or their company? So I mentioned the one thing about sideloading that people do with block storage. Sideloading has a few advantages. So first of all, if you do sideloading, or you do the first method that I showed, where you just make Athens download the stuff once from upstream, well, of course you get immutability, because it's only going to download it once, and then it's there forever. Not only that, but since Athens has all of your dependencies, everybody in your organization can point their toolchain at Athens. And that, in turn, makes sure that nobody accidentally requests private dependencies from a public proxy or from GitHub or any of the other VCS systems. So that means that GitHub or one of the public proxies is never going to know about my private github.com/super secret module package name. That's one thing. Secondly, since everybody's already pointed to Athens, that means that Athens has all the dependencies that your entire organization relies on. So that gives you auditing. If Athens has everything you need, you can go look at the Athens database, and you can see all the modules that it uses, all the modules that your code bases use, and all the versions of those modules. And since the source code is there, you can also go look at the licenses and the CVEs for that stuff as well. And then that last piece is isolation. So the simple fact that you can sideload means you can shut Athens off from the internet. You can actually shut your entire organization off to the internet if you want to. And Athens can be the thing that everybody downloads dependencies from. But then there's a bigger thing here that I see as the most important reason that people run Athens. And that's to keep the decentralization factor, right? So Athens, hopefully you've seen, is Athens is a way for you to control your own destiny and not have to rely on an upstream registry or the upstream VCSs anymore. Right? So we're at kind of a fork on the road where when we had the GitHub stuff, it wasn't perfect, but if I was a module developer or a package developer, I could push my code up to GitHub. I could own that repository forever. And immediately after I did my Git push, everybody in the Gopher community immediately had access to it. Well, now, in sort of the registry age of Go, now if I push it up to GitHub, people don't immediately get it from GitHub, and they might not immediately get access to it. Right? So that abstraction that I talked about earlier with the registry, and I put the crying emoticon, that represents the risk of not having decentralization anymore. And Athens is one little piece we can add to the system to add back the decentralization. And if we don't do a little bit of work and start running Athens and things like Athens we run the risk of losing that factor of decentralization. So I want to leave you with this. We have a download API now. We have Athens, which is one of the many systems that implement this API. And it's an open API, right? The spec is right there. I showed it at the beginning of this presentation. The API is made open to encourage people to collaborate, to build instances, or to run Athens. But it's not going to stay open unless we all actually run instances of this API. Or in other words, by running an instance of Athens or another implementation of the API, you're casting your vote to keep it open. And that's really important because otherwise, if there's only one or maybe two implementations of the API, well, it might as well be closed anyway. So I really hope that you do run Athens or you do run your own implementation of this API because you will be casting your vote to keep the module system decentralized and also to keep those privacy benefits I talked about and those isolation benefits that I talked about and those auditability benefits that I talked about as well. So if you do want to run Athens, you have questions about running Athens, or you want to get involved with Athens, we always say absolutely everybody is welcome. We're going to go out of our way to try to welcome you to the community, get you started if you want to get started contributing, answer your questions if you have questions about how to run Athens. So there's a bunch of resources up here. You can DM me on Twitter. That's also my Slack name on the Gophers Slack, AR Schles. If you speak German, I'm aware that this means bad things. So don't worry about telling me that. And of course, Gophers Slack, there's someone around almost all the time, almost all hours of the day. So feel free to come ask questions there as well. If you can see at the bottom there, if you can't see, github.com/AaronS-talks. If you go into that GitHub link, you'll see all the source code for this GoLab talk. And finally, I have stickers. So I think if everyone takes like one, I'll put them up here, and Athens stickers that have that Athens thing up there will be yours. So, and that's perfect timing. So thank you everyone so much for coming. I appreciate it.